One line. Find and replace. The pattern lists two words, mini or minivan. The string is minivan, the longer word, an exact match sitting right there. And JavaScript replaces half of it, carvan. You listed the exact word. The engine chose the shorter one, and it will make that same choice in production. Your regex is not read the way you think. Not a bug. The engine obeyed your directions. It just plays by three rules nobody taught you. Forget what the syntax looks like. A regex is not a description that the engine ponders and matches against your string. It is turn-by-turn directions, a route handed to a runner. The string is a corridor of characters. The runner starts at the first one and follows your directions one step at a time. Check a letter, move forward. And wherever the directions offer a fork, a decision has to be made. Pin the vocabulary, both languages, because interviewers speak the formal one. Your pattern compiles into the directions. The runner is the engine. One position in the string, one step in the pattern. Every fork in the directions, like mini or minivan, is a choice point. The runner drops a breadcrumb there, and walking back to the last crumb to try the other branch has a name, backtracking. Hold on to that word. It is the whole story of this series. First rule. The runner does not survey the whole corridor and pounce on the match. It attempts the full directions starting at position 0, character by character. If that attempt dies, nothing clever is remembered. The runner steps out, moves one position to the right, and starts the directions over. Position 1, position 2, a complete attempt from every position until one succeeds, which is exactly why the match you get is always the leftmost one. Second rule, the one that made carvan. At a fork, the runner tries the branches in the order you wrote them. Mini comes first, it fits. And the moment a branch fits, the runner commits and moves on. It never stops to ask whether the other branch would have been longer. That is the whole bug. Mini matched at position 0, replace swapped exactly those 4 letters, and van survived. Flip the order, minivan first, and the exact word finally wins. An alternation is not a menu the engine weighs. It is a priority list you wrote. Third rule, the famous one. The word coder and directions that say C, O, then OK, or D, then R. The runner matches C, O, and hits the fork, a choice point. Breadcrumb down. First branch, OK. O fits. K does not. The corridor says D. Dead end. So the runner walks back to the crumb, untaking every step, and tries the second branch, D, E. Fits. Then R. Match. The whole word, order. Forward on faith, back on failure. Every regex you have ever run works exactly like this. Your turn. The pattern offers 3 words, cat, car, cart. The string is cart. And again, an exact match is sitting right there. Pause the video and call it. Which word comes back? Trace it like the runner. Branch 1, cat, C fits, A fits, T meets R. Dead end. Walk back. Branch 2, car, fits completely. The runner commits. Cart, the exact match, never even gets a look. The answer is car. Not the best fit, the first fit. So why is the name of this whole tool a lie? Regular comes from the 1950s. Regular languages, a piece of mathematics. And the original matching machines were beautiful. They read each character exactly once, never walked back, and were provably fast on any input. Then programmers wanted more. Backreferences. Match whatever that earlier group matched again. No read-once machine can do that. So Perl and then JavaScript, Python and Java chose our runner instead. Breadcrumbs, walkbacks, more power, and the speed guarantee was the price. Grep and Google's RE2 still run the read-once machines. Fast but no backreferences. Your language runs the maze. 2 families, 1 trade. Remember it. It comes back in episode 8. Boss level. Same word, bat. 2 patterns, both correct. B, then at, or A, then T, and B, then A, or at, then T. Both match. Pause. What is actually different between them? Pattern 1 tries at first. B, A, P, all fit. Then the directions demand 1 more T, and the corridor is empty. Dead end. Walk back, take branch A, then T. Match. 6 steps, 1 walk back. Pattern 2 tries A first. B, A, T. 3 steps. No crumbs touched. Same answer, double the work. Now imagine a pattern where every step is a fork. That is episode 3, and it once froze real servers. Your field guide. What you assumed against what the runner actually does. You assumed the longest option wins. It is the first fit that wins. So write alternations longest first, most specific first. You assumed one smart scan. It is a full attempt from every position. Anchor your patterns when you can. You assumed failure is free. Failure means walking every path back. Fewer forks, faster regex. Trace like the runner. First branch, breadcrumb at forks, walk back on failure. Do that and no match will ever surprise you again. A regex is turn-by-turn directions. The runner takes the first branch that fits, drops a breadcrumb at every fork, and walks back on failure, restarting from every position until something matches. That is every match, in every language, every day of your career. Next Sunday, one innocent little star, the greedy quantifier, eats your entire string and then gives it back piece by piece. Subscribe so it finds you.